Hello everyone, welcome to Clean Coder YouTube channel. So today we are going to solve this lead code problem number 494, which is target sum. It's a medium level lead code problem. So let's go through the problem statement quickly. This problem says you are given an integer array nums and an integer target. You want to build an expression out of nums by adding one of the symbols plus and minus before each integer in nums and then concatenate all the integers. Okay, so it has given an example nums array 2 1. We can add a plus before 2 or a minus before 1 and concatenate them to build the expression plus 2 minus 1, and we need to return the number of different expressions that we can build which evaluates to target. So they have also provided an example. Let's check the constraints first. So the array length is between 1 to 20 and individual element range is between 0 to 1000, and sum of all the array elements is between 0 to 1000, and the target parameter which they have provided, that is between negative 1000 to positive 1000. So like from the constraint itself, like the length of the array is really small, so this is also giving an idea that even the optimized brute force solution would work, or like dynamic programming is needs to be applied in this problem statement. So no problem, let's check the whiteboard and let's dive deep into the problem statement. So this is the first example which they have provided to us, right? The example says that we have a nums array. There are 5 ones in this array and we have target 3. We can place a plus or a minus before each place. Basically we have 5 places. Okay, we can either place a plus or a minus 1 here, plus or a minus 1 here, and so on and so forth, and it it just wants the number of ways in which we are able to obtain a target of 3. This is the target, so we need to make the sum of all the individual places as this target, and we want to compute the number of ways in which we can do this. So this I have taken from the problem statement itself. They have told that there are 5 ways to make 3 using this numbers array. Let's check out how. Like the first one is we place a negative at the first position and rest of them are positive, so it gives a 3. Similarly, at second place we keep a negative one and rest of them are positive. Again it gives a sum of 3. Similarly, at third place there is a negative one and rest of them are positive. It again gives 3, and so on and so forth. So there are 5 ways in which we can obtain a sum of 3. So the answer of this test case is 5. The What would be the brute force solution? We need to think of the brute force solution, like how we can brute force this problem, because from the constraint itself it looks like even the brute force solution would pass the problem statement. So if we are given 5 places and we have 5 integers, right? We have this is a, this is b, this is c, this is d, this is e. Okay, these are the 5 integers. Okay, so here there are only 2 possibilities. What could come at the first position? It would be either plus a or minus a, right? Again, at second position there are only 2 possibilities, either plus b or minus b. Again, at third position there are only 2 possibilities, either plus c or minus c. Similarly, plus d or minus d, and plus c or minus e. So out of all the permutation, or what I say, combinations, all the combinations which I obtain, I just want to return the combinations which yield the sum as target, right? Which yield the sum as target. I just want to do that. So let's try to make the brute force tree, like brute force, how using brute force we can approach the problem statement. So let me move to the next slide. So this is the previous test case only, and this is the target which I want to obtain. This is target, and this level signifies position 0 of the array. Like I can either place a +1 or a -1, right? And this level signifies position 1. Similarly, this level signifies position 2. Similarly, this level, okay, signifies position 3, and the last level, this signifies position 4. These are all the ways in which I can keep 5 numbers at 5 places, right? Using plus and minus of that number, right? These are all the number of ways, right? What you can do is you can implement recursion, and you can calculate all the paths which yield a sum of 3. So for example, let's say I took +1 at first place, okay, it signifies this, and then I again took +1 at second place, it signifies this. Then I took a -1, okay, it signifies this. Then again I took a +1, okay, it signifies this. Then I again took a +1, it signifies this. Okay, what is the sum obtained? It's 3, right? So the path in this tree is this, right? This is a valid answer, right? This is a valid answer. So using all such valid answers, I just need to return the number of ways using which I can make the target. Okay, this is the problem statement in crux. This is the crux of the problem statement. So let's check some optimizations on this tree. Okay, so this tree I have drawn again in this slide. You can see yourself that this subtree +1 +1 +1 -1 -1 +1 -1, this is getting repeated thrice, right? Even more than that. I've just marked these 3 places, but it exists much more than this time. So what this signifies is there is overlapping subproblem in this problem, right? These tree, if this answer I have computed here only, I can skip these computations just by storing this result, right? So there exists a overlapping subproblem in this problem. So I can write here overlapping subproblem. So this part is clear. Let's move to the next slide. Okay, so I have written the brute force solution for this problem, and like if we are able to write the solution using recursion, we can say that optimal substructure exists for that problem, right? So this is the solution I have written. This is the brute force solution. Brute force solution. And what is this doing? Let me explain you line by line. So find target some ways. This is given to us. Nums array is provided. This is target S, and auxiliary function I have made. This nums is the array. 0 is the index from which I am starting, and 0, the next 0 signifies the sum which I've been able to make till that index, and final s, you can treat that as target, which we are talking earlier. So after that I'll jump in this function. So there are two possibilities here. One is positive, one is negative. So what positive one is doing, nothing but it is adding that number to sum, and sum I have initialized to 0. So this is 0 plus 1 kind of thing. And what is the second branch, negative 1, doing? It is nothing but subtracting 1 from the sum. Okay, something like this. So this branch is signifying this. Okay, so this will go on to recursion until this base condition is reached, right? When will this base condition reach? Either when I reach the end of the array, like this base condition would get hit when I reach the end of the array, when I is double equal to nums dot length. And when I reach the end of the array, if my target is equal to sum, right, the sum which I have accumulated here is equal to the target, right? What I can say, that that is a valid path. That way will return me a valid combination. So I'm returning 1 in that case, and in all other cases I'm returning 0. So this is the brute force solution I just wanted to talk about, and this is the optimal substructure in the problem. So what we can conclude, we can conclude that the optimal substructure exists in the problem, and there is also an overlapping subproblem that is present in this problem. So using these two conditions, we can say that we can optimize this using dynamic programming, and we can write a better solution using dynamic programming. So before that, let's analyze the time and space complexity of this solution. So time complexity of this solution is exponential, which is clearly evident. So time complexity is exponential and space complexity is order of n square. So these are the time and space complexities. So now let's try to write a better solution for this problem. So I am going to optimize this using memoization, because I find memoization a bit easier than writing a bottom-up solution. So I'll optimize my brute force solution using memoization technique. So let's move to the next slide. So this is the same function, I'll say, which I have shown you earlier. I've just added a lookup kind of thing. The lookup is this 2D matrix dp. No problem, let me explain you these two functions line by line. So this 2D matrix dp, I have initialized it to like the rows are nums.length plus 1 and columns are 2009. I have taken this number. You can take any number here, but like this number is just sufficient for the constraints mentioned in the problem, so I have taken this number. So after that, what is this part doing? This is nothing but initializing this matrix, each value of this matrix as positive infinity. Okay, I'm initializing each value of this matrix as positive infinity. After that, what I'm doing, I'm just calling this recursive function with all the parameters same, and now passing one more lookup for dp table, dp matrix. So what will happen is this would come in this function. Okay, so this part, this base condition is completely similar to the earlier brute force one. The difference, I would say, is this. What would happen, like whenever a value exists in the dp table, whenever the value exists in the dp table, the value at this position dp of I and sum plus 1001, this won't be equal to positive infinity. So this indicates that a valid value exists at this table, at this position. So in that case, I am returning directly that value, because that is the answer to the subproblem. So I am returning this part, and these two calls are completely similar. Now the only difference is this step, right? Instead of directly returning, whenever I have computed a value, I am storing that in the DP table. So this is the only difference from the previous version. So using these changes, you would be able to optimize the brute force solution, and the technique is memoization. So let's see what is the time and space complexity now. So time complexity now is O of n square, and space complexity is still the same, which is O of n square. So we have been able to optimize this problem using dynamic programming memoization technique. Now let me show you the difference. Okay, let me show you the difference. These are my submissions. So the top submission, this one, in this I have used memoization, and you can see the runtime is only 18 milliseconds. And the previous one is brute force solution, and you can see the runtime is 528 milliseconds. So this is a massive improvement. So this is all I wanted to talk about in this problem statement. So if you liked my tutorial, and if you have sticked till here, please subscribe to my channel, please like this video, and please feel free to add any comments. If you see any improvements or you have any suggestions, please feel free to add them in the comment section. Thanks a lot for watching. Hey guys, do check out this Instagram channel, Clean Coder Community, for all the jokes and memes related to software engineering. Thanks a lot.